a segment of a circle. Now this is a circle whereby this line here, which a line which touches the circumference of a circle at 2 points, we call this line a chord. So we call such a line, this one, this is a chord. Okay, you can call it chord AB. Now any chord of a circle divides the circle into 2 parts. Like now we can have this lower part which is shaded, and then there is the upper part which is not shaded. Okay, so the upper part is the bigger part, we call it the major segment, and the lower part we call it the minor segment. We call it the minor segment. So you can say this is our major segment, and this is our minor segment. Now, in our area of concern, now here we want to be to know how can you calculate the area of one of the segment, which could be this segment or this segment. Now, to get the area, we are interested now with this shaded part. To get the area of this shaded part, the first thing you need to do is to get the area of, if this is the center of, the area of the sector of the circle. Then you deduct or you subtract the area of this triangle. Now you'll notice that this triangle is an isosceles triangle, simply because this side is a radius and also this side is a radius. Okay, and so it's an isosceles triangle, and we can use the the formula half area equals to half AB sine theta, because we have one side of the triangle, another side of the triangle, and an included angle. So let's now see how you get this shaded area, which is the area of the minor segment. So you can say there the area of the minor segment, will be given by area of the sector, you can call it sector, or AB, the whole sector, the whole area. Then we subtract the area of the triangle AOB. So the area of the sector, we know the formula already, shall be theta over 360 times pi r squared, which is theta is the angle which the sector subtends at the center. Then minus the area of the triangle should be half AB sine theta. So now let's substitute these values here. So theta for this case is 30 over 360 times, okay, we can use 22 over 7 times, okay, this is 14. All right, you can say 14 squared because 14 is the radius, minus half times. Now the two sides of this triangle which we are already given is side 14 times the other side 14, which happens to be the two radius of the circle, then times sine 30 degrees, Now, with the help of a calculator, we can get this value, because the first part will be 30 over 360, okay, 30 over 360 times 22 over 7 times 14 squared. All right, let's see what we are getting. The value we get here. This becomes 51.333, which is recurring, minus, right, now this is by 2, 1 by 2 is 7. So we can have, this is 7 times 14 times sine 30 degrees. And this gives us 49. So once you subtract the two, 51.33, you subtract 49. Okay, is 51.333. We are subtracting 49. This gives us 2.333 recurring centimeters square, which is the area of this minor segment. The area of the minor segment, this minor segment, which is the shaded part. Now, if we wanted the major segment, we can simply get the whole area of the circle, then subtract 2.33. We would get the area of the unshaded part. So remember that is how you approach that problem, that you may arrive at the answer. Thank you.